So this is part 2 of the video. So we are finding rather the identity element for this. Okay, this is for part 2. Okay, so let me just write what we had. We had a plus e open brackets 1 minus a. So what we have rather is this. So you know that on addition the binary operation is 0. So I'm going to say a plus 0 is equal to a plus e open bracket 1 minus a. Then a plus 0 is just a. So a is equal to a plus e 1 minus a. Basically what we're finding is just e, the identity element. So what we can say, we can take this to this side. So it will be a minus a is equal to e open bracket 1 minus a. So let me wrap the top part here. Okay, so what we are going to have basically is a minus a is just 0. So 0 is equal to e open bracket 1 minus a. And if we divide 1 minus a on both sides, 1 minus a, we are going to remain with this. We're going to have 0 divided by 1 minus a is just 0 is equal to e. So identity element is equal to 0. So basically that is how you can find the identity element. Okay, let's now answer the question. We had from the past paper. Okay, so this is the question we had from 2019. Let star be the binary operation on the set of real numbers defined by a star b is equal to ab minus a plus b. Okay, determine whether the binary operation is commutative. Okay, so a star b is equal to ab minus a plus b. A star b is equal to a b minus a plus b. Okay, that is how it is. Then we are determining whether the binary operation is commutative. So for commutative, we said that if you have a star b, it should be equal to b star a. That is for commutative. Okay, so let's find b star a. What would be the value? So we're going to say a. In this case now, we'll start with b. Wherever we say a, we'll substitute b because we're starting with b. So we're going to say b a. We're just exchanging minus here. We'll start with b, so it will be b plus a. And we can see that b star a is equal to, multiplication is commutative, so that's the same as writing a b minus addition is commutative, so same as writing a plus b. And we can see that this is simply equal to that. A star b is simply equal to b star a. Therefore the binary operation is commutative. Okay, therefore the binary operation is commutative. So that's how you can answer this question. Then let's look at the second question. Using the operation defined by a star b is equal to ab minus a plus b, evaluates 2 star 3 star 4, and 3 and 4 are in bracket. So using the operation a star b is equal to a b minus a plus b, then we are told to evaluate 2 star 3 star 4. Okay, like that. So how can you evaluate this? So basically what they mean is that start with 3 and 4, because this is what is in brackets. Okay, so it deals with the binary operation, only deals with 2 things. So you need to start with what is in the brackets, because we can't deal with 3 things. Then we'll come back to what is outside. Okay, so we're going to say taking first 3 star 4, it will be equal to, wherever we see a, we'll be substituting 3, because that's the first term there. Wherever we see b, we'll be substituting 4. So it will be 3, then we substitute 4 there, minus open bracket 3 plus 4. So what we are going to have here is that 3 times 4, that is 12, minus 3 plus 4, that is 7, and this will give us 12 minus 7, that is 5. So we now know that 3 star 4, the answer is just a 5. Now let's substitute a 5 where we have 3 star 4. Okay, so we're going to say 3 star, where there is 3 star 4, we know that the value is 5, so substitute 5 there. Let's now evaluate. Okay, so now this will be equal to, well, our a will now be 2, our b will now be what? 5. So we're going to say 2 open brackets, where there is b, we substitute 5, minus a plus b. So our a is 2 plus b, it is 5. So this will be equal to 2 times 5, that is simply 10, minus 2 plus 5, that is simply 7. So 10 minus 7, that is 3. So we now know that a, okay, we now know the value of 2 star 3 star 4 now is equal to 3. So this is how you can evaluate these questions. Okay, so basically this is what you need to understand on binary operation. Thank you for watching. Have a great day.
Yeah.